Review. It's the chapter test. It's the review that we're doing. Let me grab out a camera real quick. Got it. Okay, what do we got? Remember I said I was going to start with chapter 3? Uh-oh, pause. You might all pause. Shh. You might all have aced all of your chapter final review questions, but if not, now's the time. I have not given you any hints as far as the final on chapters 4 or 5, and not even really chapter 3, and I won't unless you ask me questions from the review. So if you have no questions, that's fine, but if you do have questions, now's the time, or else once I'm done from a chapter, I'm done from a chapter. Chapter 3, anything remaining? Jaden? 11 and 20? 26. Okay, anything else from chapter 3? Going once, going twice, and sold. Okay. Word to the wise in chapter 4, when we get there, I'm only going to allow so much time because I don't want to waste your time. That's the last thing I want to do. If you want to listen, you can listen. If you don't want to listen, that's fine. I'm just trying to make sure that you guys realize I am here and I'm wanting to help and give you hints as far as the test. On the final exam, solving a logarithmic or exponential function, like number 26, would be an excellent long answer. But number 11 actually wasn't asking us to solve. Number 11 would be an excellent multiple choice because this is asking for, if I remember right, the domain, the vertical asymptote, and the x-intercept. These are great little like, hey, what's the vertical asymptote of? That's a great multiple choice question. So for ln, domain problems up there on the board. Whoever is inside the log, remember ln's are logs, we take that u or we take that whatever is inside and we set it greater than 0. That's how we always find domain of logarithms. So pretty quickly we get x is greater than -6. That's the domain. But this also points us to the vertical asymptote because the vertical asymptote, kiddos, is going to be the boundary of the logarithm. Remember, isn't it some sort of swoop? There it is. Now we do have the little 1 plus, which moves our point up, our intercept up. So our intercept's going to be weird. But swoop, well, usually happens at 0, but this got shifted where? 6 to the left. And so therefore, our vertical asymptote, we always have one for ln. In this example, it's actually going to be at -6. So when the domain says everything greater than -6, the 0 of an ln is always his vertical asymptote. One more time, it's up to you whether or not you listen, but that is a great multiple choice question on the final, asking the vertical asymptote of a logarithm. However, they also ask for the x-intercept, also a great type of question, not promising it's going to be a logarithm, but x-intercepts are always the zeros of the function when you set the y equal to 0. This is also practicing how to solve a logarithmic equation. We need to get to x. What order must we follow? -6? Horribly illegal. What would we have to do first? Subtract the 1. How do we get rid of an ln? E to the. We need to do the inverse operation. It's e to the power of. That's the only way to undo an ln. Get the ln by itself. E to the both sides. I know it's yucky, but it's right. Subtract your 6, now it's legal. And just a few of you stress so much, can I put them together? And you try to do some sort of magical, I don't even know what, transformation. Literally, it's just e to the -1 minus 6. They're not like terms. The only other way to write it is 1 over e minus 6. And I do believe that this question was asking you to put all of this together in a graph. That's the y-intercept. So technically what I would do is I did kind of already do it down here. Up here, I should say. But we would add and P.S. I've told you there's not going to be any graphs of anything except for, what did I say? Sinusoidal waves. So maybe some of those trig graphs, but not tangent, cotangent. A sinusoidal wave is going to be a long answer on the final, probably. If there is a graph, didn't I say it would come from chapters 1 and 2 or be one of those polynomial rational ones with asymptotes and intercepts and domain? So we probably wouldn't, you probably wouldn't, 4, 5, 6, have to worry about a logarithmic graph. But just to follow the instructions, 1 over e is 2.71828. It's almost 3, so 1/3 minus 6 is -5, and I don't know, a little bit. Okay, cool. So there it is. -5 and a little bit. I don't know. We guessed. We guessed. But then Jaden also had a question on this one. Why can we not, although I would be semi-proud and give you at least something for it because it shows some understanding, why can we not just do 10 to the power of both sides right now? Why am I saying 10 to the power? Because what kind of log is this? A common log. Yeah, log base 10. How do we undo a log base 10? We go 10 to the power of, but I am completely not allowed to do that until I somehow condense. I need the log to be 1. I need the log in one place. Right now it's in 2. So this is the product property of logarithms. It would be x times x minus 15. Only when the logarithm is condensed one place can I do 10 to the power of. It would be totally illegal up here to do 10 to the power of because you guys would distribute that, and that is not a legal math move. If you're curious as to why, come see me some other time. But for right now, condense the log. Now I can cancel out those two and say x times x minus 15 equals 10 squared, which is 100. Now pause. Everyone look up here. What's something I'm at least a little worried about, which you should have mastered a long time ago? Because some of you look at this and you're like, no problem. X equals 100 or x minus 15 equals 100. To factor, we must have one side equal to 0. And I'm just saying it because I see the mistake over and over and over again. This is unable to be solved until you get it to be a quadratic with everything on one side equal to 0. Now factor. I get that you like this and you really wish that worked. But wishing is not making it correct. Lacey, go ahead, kid. Oh, thank you. I didn't write the X. I appreciate that. So when I look at 100, now some of you are really overwhelmed, even with a calculator, as far as how to write or how to find the factors with big numbers. Can I show you my strategy? If worst comes to worst, big numbers, you have a calculator especially. Divide by 1. Divide by 2. Divide by 3. It's not going to work. It's a decimal. Divide by 4. Divide by 5. Eventually, as long as it has nice factors, you will get there. And your calculator could help because you could do divided by, divided by, divided by until you find a pair that works. Why am I going with 20 and 5? Because -20 and 5 fit the qualifications for multiplying to A times C and adding to B. What can I do then? No number in front. Psh, that's not bad. Pause. If you want to hear hints about the final, here's another one. Well, hints about really important math things that might be on the final. Remember the word extraneous? Logarithms have a restricted domain. Logarithms can only take positive numbers. That's it. Not even zeros. It must be positive. They're a little bit emotionally stunted. But anyway, only take positive stuff. They can't handle negative. So why am I going to cross out the -5? Because it's negative. No. Because when I plug it in, it would force the log to deal with a negative, which it will not, cannot do, would be undefined. Extraneous solutions. The math say yay because you've ignored the log, but the log would say nay, as in no. The only answer would be 20. Okay. Last call, chapter 3. Done. Chapter 4 review. Can anyone give me a page number on the chapter 4 review? Everything basic trig, radians, degrees, basic problems. What's the page number? Okay. Anybody have anything? Not saying you have to, but I'm ready. I'm not saying you have to, but I'm ready. Okay, 5 more seconds. 4, 3, 2. Which one? Water sprinkler sprays water on a lawn. Now, just a quick heads up. There aren't tons of word problems on the final. Probably should if I was a good honors pre-cal student. Teacher. But to be honest, in many ways, whether or not it's right, whether or not other teachers would hate me for saying this, I'm more concerned about the skills with the math topics that we've covered. However, still talking about this because it is in chapter 4, and it does help us review a few things. Water sprinkler sprays water on a lawn over a distance of 25 feet and rotates through an angle of 130. I'm not saying the water sprinkler goes all the way around. Maybe it does, maybe it doesn't. However, what do I know about the radius of that circle? 25 feet. If that's how far that water's going, then that's how far it's going to go in every direction. We're not accounting for wind or someone standing in the spray so it can't get past them, etc. 25 feet is my radius, 130 degrees is my angle. Find the area. Ooh. In chapter 4, did I make you write down, memorize any of those weird formulas, area of a sector, etc.? No. Why? Because I didn't let you have a formula card, and I thought it was a little bit mean. But what are you getting on the final? Formula card. So hold on. Wasn't there a chapter that had interest formulas, like PERT, and N compoundings per year? Should you maybe get that on your formula card? Why? I'm not going to necessarily test you on any and every obscure thing that we've talked about this year. However, if you have a formula card, I expect you to get on it the things that you're rusty on. And I think that would include PERT, N compoundings per year, area of a circular sector, etc. So I'm not saying I'd have hard word problems on there, crazy, out there, bearings, all kinds of weird stuff. But I could ask one or two, do you have the formula on your card? If so, it should be easy to plug in. And if not, well, you should have put it on your card. Okay? Only one or two, but this could be one of them. What is the area of a circular sector? Isn't it A equals 1/2 r squared theta? Help me out. I actually don't have it memorized. I should. Does anybody have area of a circular sector? Anybody have their book open to chapter 4 and can look in the review highlighted pages, the few pages before, and see if they find it before me? I think I'm right, but I might be wrong. Area of a circular sector. Describe angles. Use domain. What would that be? 4.1. Yeah. Page 266. Okay. So page 266. 1/2 r squared. Ooh, I'm a queen. Okay, so I'm not, because a queen wouldn't call themselves a queen. Unless they were a bee. I feel like the queen bee is really puffed up. But besides that, here we go. What is the one thing you have to remember when dealing with any of these formulas? The angle must be in radians. Aha! How do I convert degrees to radians? That's a much better big concept question. Dimensional analysis, so who's going to go on bottom? And who's going to go on top? I reduce, I end up with 13 pi over 18. Hey, this is random, because a lot of you missed it on your test with this chapter. What would the supplement be of 13 pi over 18? Supplement adds up to pi. There would be 18 out of 18 slices. How many are missing? 5. Be the complement, adding up to pi over 2. 9 over 18. No complement because he's too big, right? Just thinking about fractions. I think the one on the test was an over 12, right? I think. But anyway, you would multiply, over 13. You would multiply, you would be done. Okay, last call in chapter 4. There was a lot. 9? Ooh, that one's good because it's a calculator one and you guys weren't allowed to use your calculator. So I could ask something like this. Uh-oh, where'd it go? Okay. Number 9. Well, that's not helpful in any way, shape, or form. It says, use a calculator to approximate two values in 0 to 2 pi for which cosecant of theta equals, wait a minute, I have to go backwards from cosecant. How do we ever undo a trig? By taking the inverse, right? Oh, easy. Well, you guys, inverses are not too bad. Use second sine, second cosine, second tangent. There's no second cosecant button. AKA we should sue. AKA no, there's a formula for this, isn't there? But what the formula uses is the idea of cosecant being the reciprocal of who? So if cosecant of theta is the reciprocal of sine of theta, that means cosecant's value is the reciprocal of sine's value. These aren't angles, these are ratios. Cosecant's ratio will be the reciprocal of sines. Do you have formulas that you were supposed to highlight regarding this? Yes, you do. So you just need to go ahead and do second sine of 1 over 1.00 in radians and or degrees. Oh, no. They say radians. But how would you find 2? Question, guys, is this going to give me a positive angle or a negative angle if the ratio is positive? Sine inverse goes to positive 90 and negative 90, positive pi over 2 and negative pi over 2. It's going to give me a first quadrant angle. In the unit circle, where is the other place that sine is positive? Quadrant 2. How do I get there once I find the angle? Pi minus. How do I get there? Pi minus. So my final answer is going to be this guy and pi minus. Man, this one used all kinds of unit circle knowledge. Those are your 2 answers in radian mode. Might you have to change your mode on the final? How do you know? If the problem has an angle in degrees, be in degree mode. If the problem has an angle in radian mode. The multiple choice answers have degrees, be in degree mode. Now pause. What if you're like adding and subtracting and square rooting and you're like all of a sudden, oh, I didn't even think about the mode. Radians and degrees only matter when dealing with trig, sine, cosine, tangent, etc., the inverses, or these weird circular formulas with thetas. They only matter. The mode only matters. Please don't stress out at the end of the final if you're like, I barely thought of it. It won't make any difference unless the problem has an angle or trig. Okay? All right. Anything else on chapter 4? Going once? Kim? Yes. Kathleen? 19? 19. And then Robbie, what was yours? 4? Okay, let's do number 4 first, then number 19, then we're going on to chapter 5. Okay, number 4 gives us an angle. Now guys, to be honest, on the final, I would not give you this picture. On a final, I would probably give you something like find the 6 trigonometric functions or find these 2, because 6 takes way too much time. It's too hard to do in a multiple choice. And I would just give you a point or of the point -2, 6. I wouldn't give you the picture. I would just give you a point. You would need to graph the point, but what's so cool once you graph the point? What can you make? A triangle. With -2 as your x or your adjacent, 6 as your y or your opposite. And how would we find this one, Robbie? So a squared is 4, b squared is 36. That ends up being the square root of 40. Another way of putting that would be, not 4, sorry. Square root of 4 times square root of 10, or 2 rad 10. And with that, Robbie, hopefully Sokotoa Choshikau, all you got to do is take the ratios. Does that make sense? Okay. Kathleen, on yours. A plane is 90 miles south and 110. Ooh. Cross that out. Lo siento. Everybody, pause. Chapter 4:19. I did not make you do bearings this year. Besides just knowing northwest is that direction in that quadrant. And northeast is that direction in that quadrant. That's all I made you do. Cross out number 19. I do not need any of you to do number 19, chapter 4. All right, who has a page number for me for chapter 5? Maybe you have your test out. Maybe you have your review out. Let's look at the review first. Page? 95? Does anybody have anything they want to see in chapter 5? Number 8. T-proof? Is that smart? The last class day before a final?
Yeah.
Yes.
Because what have I already hinted will be a nice long answer on the final? A T-proof. What are my other hints for long answers on the final? Have I given you guys hints yet?
Yes.
I think I have.
Grass.
Grass of a sinusoid, domain, T-proofs, transformations, parent functions. I mentioned specifically the rational and polynomial, finding characteristics and graphing, right? Maybe solving a trig equation that needs both T-proof skills and unit circle, which would be like section 5.3. Solving logarithmic and exponential equations. Anyway, I've given a few of those hints today. So Kyle asked about number 8. Oh, he was so similar to one of your test problems, wasn't it? Oh, was it exactly the test problem? I don't know, it's awful close. What's the very first step to get full proofs on a T-proof? Rewrite. Yes, some of you missed -1 or -2 because you did not properly do that step. So sad. And I think 1 or 2 of you didn't even draw a T. Now you know for the final. This will be on partial credit. Show me as much as you can. There are 2 different things that I would say to do. Now pause. A few of you went a weird way on your test because you started changing secant squareds to tangent squareds plus 1. And I normally, yeah, that's valid. It's a Pythagorean property. But look to where you're going. Who do you want to keep? Secants. So who do you want to get rid of? So why not just get rid of the tangent squared? Don't go getting rid of who you want. Some of you are your own worst enemies sometimes. Now, some of you might have factored out a secant squared. That would have been great. I'm just trying to show there are secants. Get rid of the odd man. Tangent squared of x. I know it's weird, but it is a Pythagorean property. Now, pause. Am I giving you a formula sheet on the final? It's your responsibility to get down enough of those formulas to have them. Now, wait. Were there certain formulas that we focused on way more than others? What are the random ones that you don't necessarily need besides maybe if I put one of those random questions on the test that need a random formula? The random formulas are the ones like sum to product, product to sum. The random formulas are like the co-function formulas, the even and odd formulas. The random formulas are like the half angle ones. I'm not saying don't put them at all. I'm just maybe just put one so you kind of have an idea. I don't think you need to write all of those random ones. I could still ask like one question about it, but the main ones, the double angles, the main ones, the power reducing, the main ones, the quotient and the Pythagoreans, those are the main ones to have down. But why does it make all the difference if you plug in the rearrangement of the Pythagorean? Don't we have some math we can do? And isn't secant squared times secant squared secant to the 4th? And secant squared times 1, -1. It's a negative secant squared. What happens? Rewrite. But I'm good. Anything else from chapter 5 review? Have a party. You're done. Kathleen. 11? 9. Sorry, kid. Guys, what do you think? Left side or right side? You can't see it. Left side or right side? Yeah, thank you. I was scared for a second. Please left. Maybe just a couple of you could do right. Try the left. See if you can get there. Now's the time to start getting your old tests back into your test folder. Now's the time to start getting your old tests back into your test folder. Please take note of any ones that were missing. If you can find them, please do so I can get you some points. Start getting your old tests back into your test folder. Not chapter 5 though. Remember, I need chapter 5. Don't put that one in there. I don't know. What I see over here is cotangent, which is cosine over sine, and tangent, which is sine over cosine. I don't like cosecant and secant. So I would call them the weird or the odd ones that I want to get rid of. So I'm going to change cosecant and secant. But then I see some complex fraction mess going on, right? Just a few of you would do some horribly illegal stuff. What I would say is get common denominators. Unless you know my cool trick of multiplying top and bottom by the enclosed denominators. Otherwise, just get common denominators. When you get common denominators, you will end up with cosine plus sine over a common denominator of sine cosine. All over sine cosine. Sine plus cosine, I apologize. Just a few of you actually see that these reduce and you have 1 over sine cosine. Just a few of you might see that. Others of you might need to put this over 1 and then multiply by the reciprocal. Long story short, those do reduce. But some of you are like, well, great, that's cosecant times secant, but that's not what I need. Okay, if you ever get somewhere like this, it might be helpful to go to the other side, off to the side, and be like, well, how on earth do I? And maybe actually see that you're actually not that far after all, because isn't this 1 over sine cosine? How do you use this to help you here? Can't you go backwards and say, well, isn't that cosine squared plus sine squared? And then couldn't you take cosine squared over sine cosine plus sine squared over? Sorry, my alpha. Pause. No one get up yet. And then Kathleen, I think you see at this, we'd be good. Now there might have been other ways of doing it. This is one way. There's our cotangent. There's our tangent. That's one way to get stuck, but go to the other side and figure out the steps to go backwards. I need all of your old tests in your folders right now. You're allowed to walk out of here with chapter 5 if you're finishing it by the end of the day, but everything else needs to get in that folder and back to me as you walk out the door. All right, cool kids, you know what to do. Work on that final review. Maybe tutor others in this class that are struggling, de nada, for tutoring hours, off-campus tutoring hours. I'll take the test folder, hand it to me, that's your ticket out the door. If I don't have it from you, you don't get to leave. Gracias. Maybe work with some pre-cal kids on their final review, some questions which might be the same as yours for tutoring hours. Gracias. Thank you.